Let's take a look at the questions on homework number 16. The first topic is determine if a set of points is a function. So when you're looking at a set of ordered pairs or a table, you are looking for inputs that have different outputs. Okay? A function cannot have any repeating x values with different y values, right? You can repeat an x value as long as you repeat the y value. But you can't have repeating x's with different y's. So in this question, it says which set of ordered pairs is not a function? So if we want something that's not a function, then we want to find a repeating x value. That's what we're looking for. So let's scan these x values and find a group that has a repeating x value. Oh, there it is. A repeating x value, 7, with different y values, 1 and negative 8. This one is not a function. Let's try again. This one says which set of ordered pairs does represent a function. So this time we want no repeating x values. No repeating x values. Oh, that has a repeating x value. That's not a function. Ooh, this one looks good. This one has a repeat. This one has a repeat, so that's the winner. So this one is a function. So again, to recap, you are looking for x values without repeating y values. So let's take a look at the second topic. Determine if a graph is a function. Well, the rule is the same. You still want no repeating x values. But it's hard to find repeating x values when they don't tell you what the x values are. So since this is the x-axis, if you were to repeat an x value, that means that you would have a point, let's say here and here. And that means you would fall on the same vertical line. So what we're going to do is we're going to do something called the vertical line test. We're going to take our finger or our pencil and we're going to, here we go, I'm going to take my vertical line, I'm going to drag it, and if it touches in more than one place, you fail the vertical line test. So this is not a function. Again, for every question, you draw or take your pencil and scan it across the graph, and if you touch it twice, like we do here, you are not a function. So this is not a function because it fails the vertical line test. This one is not a function. It would fail this vertical line test. It's not a function. This one here is a function because when I slide my line across, I never touch the graph twice. So this one is a function. Okay, let's go back and take a look at the next topic, finding rates. So a rate on a graph is either a rise over a run, or in a table, a delta y over a delta x, or with points, it's y2 minus y1 over x2 minus x1. So let me zoom in here so we can find two perfect corner points. And from there, we can count the rise and the run. So let's see, 1, 2, 3, 4, 5 up, that's positive 5, and 1 to the right, that's positive 1. So my rate is 5. If I reduce 5 over 1, I get 5. So I'm going to zoom back out, type my answer here, and try the next problem. All right, this one is a different format. This one is a table, and with tables, we're looking for the pattern of the y numbers, and then the pattern of the x numbers. So this one is first. This side is first because this is the y's. And if you don't know the pattern between these two numbers, try finding the pattern between these two numbers. So 6 to 11 is up 5, and 8 to 12 is up 4. Make sure you put your numbers in the right order. The y pattern over the x pattern. So 5 over 4 is going to be your solution. So let's type that in the answer box here. 5 over 4. All right, this one is the third type of format you can be asked. And when you are in y equals form, you're simply looking for the coefficient of x. So we're going to type -5 in here, and we'll be done. All right, those are the three forms you can be asked. Let's take a look at the next topic, comparing rates. So again, we're going to do the same thing as before. We've got our different formats, and we need to read carefully to see what they want. They want something that has the same rate of change as this equation. Well, this equation has a rate of change of 4. So 4 is our magic number. Now we have all these different formats. We have 2 graphs and we have 2 tables. Well, I can tell you right now, by looking at this graph, which is going downhill, that its rate is going to be a negative number. So it definitely is not the same as +4. So let's take a look at A over here. I see 2 corner points, and I'm going to start counting. 1, 2, 3, 4 is the rise, and +1 is the run. And that is a match. So I don't even need to check these tables. So I'm going to choose A as my match, and we'll move on to the next question. All right, this question says which one has the same rate of change as this equation? Well, I don't even see a number in the slope position, so that must mean it's an invisible 1. So my magic number is +1. I want something that is the same as that. Well, take a look at this one again. It's going downhill. That means it has a negative rate. That means it's not the right answer. All right, option A over here this time is a table. So let's use the rule for tables, which is the change in the y and the change in the x. So I'm going to choose these 2 points. To get from 9 to 25, I go up 16. And to change from 2 to 6, I go up 4. Set the fraction up properly. 16 over 4 is the same as 4, which is not the same as 1. So this one is out as well. So let's scroll down the page. Again, our magic number is 1. So let's take a look at this graph. I see 2 corner points. It looks like it has a rise of 1, 2, 3, 4, 5, a rise of 5, and a run of 1. And that is not the same. So let's do our final pattern check here. So let's see, from -5 to -3, that's an increase of 2. And from -4 to -2, that's also an increase of 2. And 2 over 2 is the same as 1. So that's the match. So letter D. All right, let's go back and take a look at the next topic. Writing the equation of a line that passes through 2 points. So this is the equation of a line. So I need to know a y-coordinate, an x-coordinate, and a slope number. Well, I have 2 x-coordinates and y-coordinates, and I only need to use 1. But I have no slope information. So the slope is this formula, also known as the giant subtraction fraction, right? So let's take our y-coordinates here, 3 and 1, and find their difference. And then let's take our x-coordinates here, 3 and 6, and let's find their difference. And when we do that, we will find our slope, 2 over -3. So that number is going to go here. Now, in order to find the b value, I have to erase and replace all 3 of these numbers. So right now I know, I'm going to clear all my writing. Right now I know that m is, what was it? -2/3. So m is -2/3. So now I want to erase my x and y and replace my x and y with either one of these points, but not both. You know what? I'm probably going to choose this one because the x number and the y number are the same. So if I mess it up, I'm still going to get them in the right place. And this is what I mean. This is x and this is y. And if you put 6 here, you would be wrong because the number that goes in this position is the y number. And the number that goes in that position is the x number. So since I have this here, I'll just go with these points. But this one probably would have been easier because I couldn't get it wrong. All right, so 1 is equal to negative 2/3 times 6. Use a calculator if you need to. Negative 2 times 6 is negative 12. Negative 12 divided by 3 is negative 4. Now all I need to do is get b by itself. And now I have my final number. So the only two numbers you need to answer this question, y equals mx plus b, the only two numbers you need are m and b. So I found m, it's negative 2/3, and I found b, it's positive 5. So now I have my equation. Y equals negative 2/3 x plus 5. Y equals negative 2/3 x plus 5. All right, one last time. Again, I have to find my slope value first. I need a giant subtraction fraction, and I start with my y's. So negative 4 minus 6. Then I start with my x's. 4 minus negative 1. And then I compute using a calculator if I need to. Negative 4 minus 6 is negative 10. 4 minus 1 is 4 plus 1, which is 5, which gives me a slope of negative 2. So that is going to be my m number. And now I need to erase and replace my x and y values. And I think I'm going to choose, probably doesn't really matter. I'm going to choose this one just because it's first. I don't know. Negative 1 is x, 6 is y. So this is the correct setup. 6 is equal to 2 plus b. Subtract 2 from both sides. That makes b equal to 4. So this is my m, this is my b. And now I write them in the equation. So m is negative 2 and b is positive 4. And this is what I'm going to type. Y equals negative 2x plus 4. All right, let's move on to our last topic, transformations. So I'm going to ask you to do this 2 times. The first time is kind of a learning activity, and the second time you'll actually have to do it yourself. So we're going to work on translations or slides. So the first one is a guided slide where they ask you to count the boxes of how you translate figure A, which is blue, onto figure B, which is green. Now, when you translate, you can never move diagonally. So if it looks like you're moving diagonally, you're really moving 2 ways. You're moving up or down, and then you're moving left or right. So you're moving 2 directions, up or down, left or right. So it looks like the first one is the left or right question. The first one is the left or right question. So let's decide how far we have to move to get from blue to green. Well, it looks like we have to move to the right. So let's just pick one single point. I'll pick this one because it's pointy and it kind of sticks out, and I can really see it well. So how do I get it from here to line up with it over there? So it looks like I'd have to move over 1, 2, 3, 4 units. So we're going to select to the right, and we're going to type a 4 here. All right, so that would get my point over to here, and now I want to get my point up there. So I have to move up 1, 2, 3, 4, 5, 6. So take a look, right? I have to move up 1, 2, 3, 4, 5, 6. See how I'm lined up now? So this time we're going to click up and 6. Once we click try, we'll find out if we're correct. And if we're incorrect, they'll just make us do it again. We'll try again. So since I got it right, it's going to say you're correct, plus press submit to get credit. All right. For the last topic in the homework, you don't get to try it before you click submit. You actually just have to plot it yourself. So read carefully which way to move the points. And you're going to move all of the corner points. So you're going to have to make 4 plotted points. So first thing I'm going to do, right, with my mouse is I'm going to pick any random point I want, and I'm going to move it 5 units to the right. 1, 2, 3, 4, 5. But don't click it. Move 4 units up. 1, 2, 3, 4. Now I'm going to click my mouse. Okay, so I plotted this point. Next is this one. Again, 1, 2, 3, 4, 5 units right. 1, 2, 3, 4 units up and click. Next point, start from the original. 1, 2, 3, 4, 5 units right. 1, 2, 3, 4 units up and click. It's okay, I know the shape is not right, but that's because we haven't plotted our last point. 1, 2, 3, 4, 5. 1, 2, 3, 4. And there we go. The shape should look similar. And then we click submit. And we'll watch as it slides, and we are correct. Alright, again, you pick any corner point, and you move it the correct amount of units. 6 units left, 2, 3, 4, 5, 6, and click. 6 units left, move 5, 6. Oops, sorry. I only did 1 move. It's 6 units to the left and 1 unit up. Click. 6 units to the left and 1 unit up. Click. 6 units to the left and 1 unit up. Click. And then you submit. All right. That concludes the tutorial for homework number 16.